Hi folks, this is question 10. Now here we need to show that OB is 120. So we need to show that this here is 120. So the reason, it's simple enough really, but it's hard to explain, or it's hard to maybe write down. So you know that all of this down here is going to be 120 because that bit there is 100 and that bit there is 20. That's what's given to you. So RT is 120, or the distance of RT is 120. Therefore, that has to be the same as this distance in here, N to O, because it's just, they're both sides of that rectangle there. So NO is the same as RT. Therefore, so it's the other side of the rectangle. And then, so really that then is just the radius of the sector. So that there has to be the same as, for example, that there to be the same as that there. They're all radiuses of the sector. So therefore OB is 120 as well. So they're all radiuses of the big circle. Right, show that BOT is 41.4 degrees. Well, the very top of the whole shape there was 180, so all that across the top is 180. Therefore, half of that is 90. So we know that 90 is the distance from O to T there along the bottom, and we also know that it's 180. Sorry, it's 120. The thing that we just found before, from O to B. So you can make a little right angle triangle there with that. So that's 90, that's 120, and we're looking for this angle here. So we'll call that theta. So cos of theta is equal to the adjacent over hypotenuse. So 90 over 120. And then theta would be equal to 41.4. It's what you were asked to show. So that's the second part. Then work out the area of A, B, B dash, A dash. Right, well, just get rid of this here for a second. So we know that the angle in there, that angle is 41.4. So yeah, we need to get what that side there is, just that bit in there. So we need to figure out what the little small sector is. Getting the area of the big sector shouldn't be too bad, but we need to figure out what this bit is here, because that's the radius of the small sector. So that's what I'm doing here. So if you make a little right angle triangle there, I'll just make it bigger here. We've already found in the last part that this is 41.4. We don't know. Yeah, we do know that this is 20 over here, because it's just going to be the same as the outside over here, and we're trying to find out what that is. So I'm going to use sin here. So sin of 41.4 is equal to opposite over hypotenuse, so 20 over x. Bring the x to the other side, you get x sin 41.4. 20, and then x is equal to 20 divided by sin of 41.4, and that tells us what x is, so that's 30.2429. Right, so what we've worked out then is the length of the radius of the little sector in there. Now we already know as well that that angle there is 41.4, and then the same the other side, that there has to be 41.4 as well. So to get the angle of the middle of what we want, we're just going to do 180 minus 41.4 and minus 41.4 again, and that should give me 97.2. So that gives us all the things we need then. So to get the area of any sector, it's going to be theta over 360 pi r squared. So I'm going to do the big sector first. So all of this here, so that area I'm working out now. So that would be 97.2 over 360 times by pi times by the radius. The radius of the big sector is 120. But then I'm going to take away the area of the small sector, so the little one in here. So this little one. I found out already that the radius of that is 30.2429. The angle will be the same. At the center it's 97.2 over 360 times pi times 30.2429, and then so you can go to the calculator, then you can take away all of those, or you can put the whole thing in there, take them away, and we get 11438.69, and they wanted it to the nearest centimeter squared, so it'll be 11439. Sorry, when you were putting that in as well, they should have been squared there. Right, for part B then, it's just this right angle triangle here, and it's to use cosine rule anyway. So we're just going to use cosine rule with that triangle. So a squared is equal to b squared plus c squared minus 2bc cos a. Right, well the top of it has to be 180 because the whole top there is 180. The angle is 105 degrees, so that's the angle. And we don't know what the side is, but we're going to let it be equal to x, and because it's symmetrical, x has to be the same. It has to be the same on both sides. So I'm going to put it into the cosine rule then. So 180 squared equals x squared plus x squared minus 2 times x, so minus 2x squared cos of the angle, which is 105. So we get 32400 equals 2x squared minus. Now if you do 2 times cos of 105, you should get 0.5176, and then the x squared is there obviously. Right, so if you bring that cos ended up being, cos of 105 ends up being a minus actually, so that'll change that into a plus. So you can combine the two x squared, so you just get 2.5176. X squared is equal to 32400. Bring that across and divide it, and then you'll have to get square root of it. So x is going to be equal to square root of 32400 over 2.5176, and you should get 113.4 in the end. And that's equal to x, so that's just using cosine rule. It's not too bad really. Okay. So for the part C, so she's just passing traffic lights. So each time she passes a traffic light, there's 3 different options for what it could happen. It could be a red, a green, or an orange. So it's just going to be 3 to the power of 5. 3 times 3 times 3 times 3 times 3. So each of those 3s represents a different traffic light. It's just 3 options each time, and that just gives us 243. So that's for the first part. Now we're going to follow a similar type of logic for this bit then. So the first light, there's only one option. It could only be red. The second light, we still have 3 options for it. The third light, we still have 3 options for it. The fourth light, we have 3 options as well. But then the fifth light, it's not red, so therefore it could be amber or it could be green. So we have 2 options. So just multiply all those numbers together, and you get 54. Then the last part, so it's a nice enough last part of a question. So if you're to think about the first light has 3 different options. Then the second light can't be the same as the first one. So whatever the first one is, if the first one was red, well then it could be amber or it could be green. If the first one was amber, then it could be red or it could be green. So no matter what the first one is, you only have 2 options for the next one. And then the one after that, again, no matter what the second one is, you're going to have 2 other options for the next one after that. And then it's the same for the last 2. So it's 3 times 2 times 2 times 2 times 2. And we get 48 in the end. And that's all. And then that's it for that question and for that exam paper.